We have one more operation we can do with vectors, and this is called the cross product. And what we're looking for is a vector that's orthogonal to two given vectors. So I'm looking for a vector orthogonal perpendicular to two other vectors. And we use this, we have something called the cross product, and a product that we use, and it's the cross product, or sometimes we call it the vector product. And in this case, unlike the dot product, we get another vector out of it. So I'm going to define it. If I have u, which is u1i plus u2j plus u3k, and v, which is v1i plus v2j plus v3k, then the cross product is another vector, and it's u2 v3 minus u3 v2i minus u1 v3 minus u3 v1j plus u1 v2 minus u2 v1k. And notice we can only use this for three-dimensional vectors. We can't, in space, we can't use this in the plane. So the much easier way to look at this is to look at this as matrices. So I don't know if you remember, if I have a matrix A, B, C, D, and I put these lines, that means determinant, and the determinant is just AD minus BC. When I have a three-dimensional matrix, so I have something like this with A11, A12, A13, A21, A22, A23, and A31, A32, A33. If I want to find the determinant, I have to look at it a little bit differently. So first I take this one, I cross out the angle and row, so it's A11, and it's times the determinant of A22, A23, A32, A33. And I subtract, when I look at this one, A12, and times the determinant of what's left, so that would be A21, A23, and A31, A33. And then I add again the third, A13, and that's times the determinant of what's left, so that's A21, A22, A31, A32. So that's when I do the determinant. And so the dot product is very similar. The only difference is I have U cross V, so the cross product. And what that equals is I put I, J, and K in the first ones, and I have U1, U2, U3, and V1, V2, V3. And so I have U2, U3, V2, V3, the determinant times I, minus U1, U3, V1, V3, J, plus U1, U2, V1, V2, K. So that's a little bit easier way to remember it than looking at it here with a definition up there. So we'll do some examples.